that you've abstracted the resources, which means that the workloads are no longer tied to a particular machine. But you could say, well, that's just virtualization. But then there's this orchestration layer, which means that you can motion virtual machines across. And even more importantly now, they've got the hooks for external clouds, so that if you want to push your test and development workloads into a public cloud, because you say, well, that's not very sensitive to me, because I'm not going to put any customer data there, I promise. Then you can, this is going to allow you to do that. So that's just definition of private cloud. If anyone says to you, come on, quick, do a security review. Quick one on this, government clouds. The US government just announced apps.gov. And for those of you that have got iPhones and access the App Store, this is like the government cloud version of that. So the idea was that the new CIO over in the US wanted to, reduce a lot of bureaucracy around how other bureaus would kind of get resources. So they came up with this. And but so I don't know what like my government's doing. Does anybody know so if you're not from the US, does your country have any stated strategy around cloud that you've heard of? Because that's the only one I've really come across. No, everybody's shaking their heads. Then of course there's Homebrew Cloud, and this is a real photo from the internet, so it must be true. And this guy brews all his beer, and for some reason keeps it next to his open computer and disk drives. I have no idea, but I just included it because you can actually download a cloud platform. So Canonical, the commercial support people for Ubuntu, you can download cloud software. Like you can literally have your 5 machines at home, and you can put cloud software on there and run your kind of mini private cloud, which I'm encouraging people that want to do vulnerability research. That's a great way to do it without getting into any trouble. So, but you see all this stuff. You see these diagrams with crazy graphics and clouds and platform as a service, infrastructure as a service. It all sounds a bit gobbledygook. And as Douglas Adams once said, very wise words for many situations in life. Don't panic. And he's right, because if we look through, which layer are we talking about? Are we talking about internal, external, proprietary, blah blah blah? We can get to the point where this is something that's kind of closer to what we know. So what are the concerns? And there's some really obvious ones, so I'm going to go quickly through those, but I kind of want to include them in case people haven't really read anything on it. And what I'm trying to do here is focus a bit more what's cloud specific, because there's a lot of concerns which are not cloud specific. They're just like IT security in general. So this is just to the point that you can't go and visit a Google data center. So if your company who is being courted by Google, because Google's talking to lots of enterprises, unless you're a huge company, they're not, as I said already, they're not going to invite you to the data center for a cup of tea and a sit-down chat with the administrators. So let alone going into the basement. So you're potentially never ever going to see the place where your data is processed. And even if you did, because the data centers are, they're not in their own clouds, it's like one fabric, it doesn't really matter, because your data, is likely to be copied to multiple places just for resilience anyway. So this initial thing of can you let go enough to allow that to happen, which is kind of, for security people, a really kind of big psychological jump really. The other one is uptime. I've never seen so much hot air on the internet, except for when Gmail goes down, then Twitter nearly goes down because everyone's saying, is Gmail down? And the same for when Amazon EC2, when their cloud crashed, same deal. Everybody's really worried about uptime, and in the SLA they generally only guarantee 99.9%, which a lot of enterprises say, that's ridiculously low, we do 5 nines. But when you actually work in enterprise, you often think, well, maybe 99.9 isn't so bad after all. So I kind of think this is a bit of a red herring, but a lot of people like to talk about uptime as a big issue. Lock-in. So let's look at the 3 layers again. If you're doing infrastructure as a service, what is the lock-in? well, you're operating on a kind of virtual machine level, so you need to be able to get your virtual machines out of that provider if you choose to go to another provider. So the lock-in is if they don't provide a way for you to get the machine out, or if the format is specific to that provider. How do you port your virtual machine over? So there is an initiative, the OVF, which is trying to define a standardized virtual machine kind of format package. But platform as a service, that's the worst one. That's the ultimate lock-in, because you have lock-in at 3 levels with platform as a service, which is, one is that let's say with Google App Engine, you've coded some Java application. Your CIO is really happy because your Java application should run, you should get to debug that everywhere you choose to run it, not just on Google. But the thing is that you're coding to their back-end APIs. So you're coding to Bigtable, which is their data store API. That's the name of the software, but you're coding to that. So you're not doing relational database lookups. You're doing kind of the Google version of database lookups. And then your data's in there as well. So you've got really these 3 levels of lock-in. That's not necessarily bad, and I'm not saying you shouldn't use Google App Engine, but it's obvious that before you start putting too much stuff in there, you need to think about, well, what's your exit plan for the day that the Federal Trade Commission decides to shut down Google App Engine for a week or something, which they're under quite a lot of pressure to do. Not specifically Google App Engine, but a whole bunch of Google services. Software as a service, you could say that's the ultimate lock-in, but it's not, because there's enough players that there's competition. You can say, right, well, one of the things that software as a service providers are really keen on doing is showing how easily you can get your data out. Multi-tenancy, this is really just like shared hosting gone nuts. And why is this interesting from a security point of view? When you're designing a shared system, you have different layers that you can do the sharing at. So one layer would be, I'm going to give you a dedicated back-end database. So George, all your stuff, all of your business's data goes into that database. Well, okay, so if someone does like a SQL injection attack, they're going to have to do quite a lot to get out of that database. Depending on how it's configured, but only one customer's data is exposed. Whereas if you are in let's say a shared database, but you've got your own schemas, so there's kind of a different namespace for each customer's data. In that case, they're kind of closer because they're obviously in the same database. They need to figure out, the other customer's schema and if they can access it. But where it tends to boil down to for performance reasons is they just put all the customer data in like a single table for a particular type of object. So you end up with all the customer records in the same table, just separated by some kind of customer ID. Now, this isn't new. This is how a lot of websites have run for years. That's the way they've been designed. But of course, when you talk about a SQL injection hole, then suddenly it's a lot easier to get all the other customers' data. So, even design choices like that, which the cloud providers are making on your kind of behalf, and they're kind of questions you would be interested in, because whenever you invest in a new technology or service, you want to know how resistant is it to attack. We all know that everything can be broken into, but kind of how easy is it? And so asking about multi-tenancy. Another one is change control. There's a quote from one of the senior vice presidents at Google where he said that one of his engineers once described when they make changes to the Google web search, it's like changing the car tire on a car that's going 60 miles an hour down the motorway. Yeah, and you suddenly think about that. Now, I'm used to downloading software, and if it's Linux software, there's a change log. Yeah, I can look at that change log. Oh, what did they change between version 1.3 and 1.4? Well, do you see? I don't see any change logs on Google or some of the other providers. Sure, they might tell you if they're doing something that will affect your experience with it. So if they change the user interface, but basically you've got like this, nuts change control going on in the background with all these moving parts, and they're obviously doing a pretty good job most of the time because it's not crashing anything. But from just a boring kind of change control perspective, that's pretty significant, and the implications of that going wrong. And also from an assessment point of view, let's say that you agree with company X that's a provider. I'm going to hire a pen test company, and they're going to come and pen test your stuff.